Yeah. So, good afternoon, everyone. In today's session, we'll be discussing about radial basis function network, which is the next concept of our given syllabus. Okay. So, a radial basis function network is also similar to the one what we have discussed about the artificial neural network, but there are some small minor changes which we need to ensure while talking about your artificial neural network with respect to your radial basis function. And also while explaining about support vector machine concept about the different types of kernels, I have said that rbf, that is radial basis function, is the by default kernel for this support vector machine, which is a classification method. So there we have used this radial basis function to separate the hyperplane between two classes. That is, if you want to separate your data linearly whenever you are having nonlinear data, then we actually use this radial basis function. In the same manner, now with respect to your artificial neural networks, we will be discussing about this radial basis function. Okay, so generally people when people talk about neural networks or ANN, they are referring to multi-layer perceptron. So as I said in the previous session, perceptron is nothing but a neuron here. It is when you're talking about single layer or multi-layer neural network, it is nothing but a multi-layer perceptron. So each neuron in a multi-layer perceptron takes the weighted sum of its input values. That's what we have seen in the architecture or model of your ANN. That is, you'll be having a set of input values x1, x2, and so on till xn, and you'll be having some weights. The dot product of that will be considered as the summation function. That's what we talk about different thing with respect to your multi-layer perceptron. So a single layer single MLP neuron is a simple linear classifier, but complex non-linear classifiers can be built by combining these neurons into a network. So when we talk about a multi-layer perceptron as a single network, it might be a simple classifier, but whenever you are combining many multi-layer perceptrons, then it might lead to a complex network. At that time, the RBFN approach might be useful. Yeah. So the RBFN approach is much more initiative than the MLP, that is multi-layer perceptron. So compared to this multi-layer perceptron, radial basis function network is much more easy to understand. That is the meaning of this sentence. Okay. So here you can see the statement. The fourth point here is indicating about what actually is this RBFN. So an radial basis function network performs classification by measuring the inputs similarity to examples from the training set. So you'll be given set of input values with respect to the training set, and that from the training set some set of values will be considered, and it will be classifying the things. So each RBFN neuron stores a prototype, which is just one of the examples from the training set. So in the training set, you'll be having lots of data points, and among them, only one value will be chosen, and it will be forming a prototype. Okay, so when we want to classify a new input, each neuron computes Euclidean distance between the input and its prototype. So this is much very very important concept with respect to your radial basis function network. So the important metric to be learned or understood here is you will be using Euclidean distance function. So initially from the training data set, a point will be taken and a prototype will be formed. And whenever a new point is given as an input to classify, then Euclidean distance is computed between the input value and the prototype value. So with respect to that, only a decision will be made whether what the output what you're getting is correct or not. Okay, so it is similar to your KNN classification algorithm. So even in KNN classification algorithm also, we use Euclidean distance to compute distance between the previously available points and the new points, and accordingly we classify the things. So that's the reason radial basis function network also is similar to your supervised learning algorithm, like your K nearest neighbor. The same, the both the algorithms we are using Euclidean distance as the metric to understand the difference between the points. Okay, so roughly speaking, if the input more closely resembles the A prototype than the class of B prototypes, then it is classified as class A. So here you are having two classes, class A and class B, and the new input value, if it resembles the similar to class A, then the output will be given as class A. And if it resembles similar to the class B, then the output will be considered as class B. So the distance is a very important metric when you are considering your radial basis function. Okay, so this is a sample representation of this RBFN architecture. So here it is similar to your ANN model. You will be having input vectors or the x1 x values here, and here you can see mu is indicating a prototype here. So mu is the prototype to compare against. So whenever a new value is given, it will be compared to the prototype, the distance will be calculated, and a score will be given. So here you can see there are nothing like hidden layers here. So the you will be having RBF neurons which will be used as a prototypes to compute the score. So once the score is obtained, you will be having some weights, and that weights will be given as the categories here. Here you can see category 1 weights indicated in green color. Likewise, if you are having many categories, they are indicated with different color here. Okay, so finally they will be calculated as a sum, weighted sums, and you'll be having many categories wise scores which will be used for a decision making. So don't get confused with the actual architecture of your ANN. So in your ANN you are having input layer and output layer, and in between them you are having some hidden layers. But coming to your RBFN architecture, you'll be having some input vectors, and you'll be having a prototype representation that will be used to calculate a distance of newly arrived point, and that point will be considered as a score which will be then added multiplied to the weights, category wise weights, and that will be summed using your dot product. Okay, that's thus we compute this radial basis function network. This is the architecture which everybody need to understand or keep in your mind about the difference between ANN and this model. Okay, yeah. So talking about this radial basis function network, here you can see you'll be having some input values, some weights, then you'll be having some radial basis functions, that is the prototype values will be given, and distance between points is considered, and then it converts the values into linear weights. So here you can see here the difference between this layer and here you are having weights which can be any values, but once radial basis function is computed, the weights will be given as a linear weights, then only appropriate output can be obtained. Okay, so we at least need one hidden layer to derive a non-linearity separation. So whenever your data is not properly assigned, or whenever data is non-linear, so you at least need one hidden layer to get into that. So RBNN, what it does is it performs or it transforms the input signals into another form which can be then fed into the network to get linearly separable. So that's what is represented in the architecture here. So you can see RBNN transforms the input signals into another form. Thus, it is getting some linearly separation. Okay. Yeah. 1 second. So RBNN is structurally same to like your multi-layer perceptron, that is MLP. The radial basis function is so named because the radius distance is the same argument to the function, that is weight equal to RBF of distance. So you can see here distance will be computed, then RBF function is applied, and thus weights are obtained. That's why the name is given as radius basis function network. Okay, yeah. So here this is a simplest representation of this RBFN network. Here you can see x1, x2 are again the input values. Here this is the prototype, which is a mu value, and with respect to that, linear weights are computed. And whenever there is any difference in the output, then you will be having some bias. A bias can be computed, and thus output will be obtained. Okay, so basically RBNN is composed of an input layer, one hidden layer, and an output layer. It is strictly and you need to keep one point in your mind, which is very important difference between your multi-layer perceptron and RBFN. That is, in RBFN it is strictly limited to have only one hidden layer. You are not allowed to have multiple hidden layers. Only one hidden layer can be allowed at this point. That is okay. So we call this hidden layer as a feature vector. So basically RBFN increases the dimensions of this feature vector. Okay. So let's now talk about what are the uses of this radial basis function network. One second. So we'll be talking about use of RBFN. So there are some applications where a radial basis function network can be applied. Like it can be applied for time series prediction. It can be applied for classification. It can be applied for system control. So these are the various uses of this radial basis function. Okay. So yeah, here you can see one important observation. So in the field of mathematical modeling, a radial basis function network is an ANN that uses radial basis function as activation function. So instead of an activation function here, you are having a radial basis function. So there is no need of any activation function at this point. Okay. Okay. So yeah, that's all about your basic radial basis function network. So let's move on to the next concept of your unit 4, that is design issues of artificial neural network. So designing an artificial neural network is not a much easier task to a software developer or system developer. It involves many things which we need to understand in today's session. Okay. Yeah. So this is the basic representation of artificial network. So you are seeing many architectures in this presentation because the understanding of this ANN with respect to the different computations should be very clear. So you'll be having some weights initially x1, x2, so on till xn, and you'll be having weights, and you will be summing, or sigma function will be calculated, and then the dot product will be computed, and it will be transferred to the output path. And sometimes you can see there is a loop here. Whenever there is a problem with the inputs and outputs obtained, then you can loop back and correct your weights, and accordingly you can get your output. Okay. So here this is the processing element, that is whenever your inputs are obtained, your weights will be computed and processing will be done. So this is the formula used to compute the dot product of your artificial neural network. But how a designing can be done with respect to this artificial neural network. Okay. And let's see what are the different design issues with respect to your ANN. So as a developer must go through a period of trial and errors in the design decisions before coming up with a satisfactory design. So he need to look into n number of possibilities. Like he need to see how if I add some weights, what is the difference? If I include some, if I decrease some weights, what is that I'm getting? Likewise, he need to go into n number of trial and error methods. So the design issues in neural networks are complex and are more concern of system developers. So developers need to look into a number of trial and error methods. Then only an appropriate design will be obtained for this artificial neural network. So here we have listed some key designing issues with respect to your neural network, or it is about your artificial network. So the first one is arranging neurons in various layers. That is, we will be seeing about this point in the next slides, about what are the various layers which we already discussed, and again we'll be having glance at them. The next one is deciding the type of connections among neurons for different layers, as well as among the neurons within a layer. So with respect to connections, that is single layer feed forward or multi-layer feed forward. So that's what we'll be seeing in the next slides about the key design issues with respect to artificial neural network. So deciding the way a neuron receives input and produces some output, and also determining the strength of connection within the network by allowing the network learn the appropriate values of connection by a training data set. That's what we have seen in the radial basis function, about how to take a training model and form a prototype, and then decide about the distance metric. That's how linear weights are computed. So these four are the major designing issues, or the key points to be noted about how to design a neural network. Okay. Yeah. Let's talk about each point now. That is, first one is about uh, yeah, the layers, input layers in your uh, artificial neural network. So here you can see the basic ANN model has three layers: input layer, hidden layer, and output layer. So sometimes hidden layers can be many. So in our representation, we are having only one hidden layer, but basically, yeah, you will be having many hidden layers. So the process of designing a neural network is an iterative process, which can, that is because of the n number of hidden layers, it can go for n number of iterations. Yeah. So the figure here is representing three different layers, that is input, output, and the hidden layer. So the input layer will receive the inputs from the neurons, and the output layer will produce the output. So the process continues until a certain condition is satisfied, or until the output layer is invoked and fires the output of the external environment. So here, with respect to this input layer, there is one important issue, that is to determine the number of hidden neurons the network should have to perform its best. One are often left out to the method, that is trial and error. So because you are having a key challenge, that is you need to go for a number of trial and error methods, you need to choose one, whether you need to have one hidden layer or more than one hidden layers. That is one of the key issue about this designing of your ANN. So if you increase the hidden number of neurons too much, you will be getting an overfit problem. So overfit is, that is, suppose if you are having four hidden layers, and if you are unable to process all those hidden layers, then that will be a problem for you. The net will have a problem to generalize. The training set of data will be memorized, making the network useless on new data sets. So whenever you are having new data sets with respect to your training data set, and if you're mentioning appropriate hidden layers, that will be causing some disturbance. Okay. Yeah. Next one is communication is the second key issue which we need to discuss with respect to your ANN. So neurons are connected via a network of paths carrying the output of one neuron as input to the other neuron. So because each neuron will have connections, so you need to because one sometimes if it is single layer feed forward network, it is only unidirectional. But if it is a multi-layer feed backward network, it can be a bidirectional. So according to the direction of the information being passed, you need to send the information. So a neuron receives input from many neurons but produce a single output which is communicated to the other neurons. So multiple neurons will work to get a single output. So with this aspect, the communication between neurons is a key important factor in the designing issue. The neuron in a layer may communicate with each other, or they may have not have any connections. The neurons of one layer are always connected to the neurons of at least another layer. So communication and the types of connection is one important thing to be understood as a designing issue of this artificial neural network. And talking about the in-depth concept of your connections. Connections are classified in two types, that is interlayer connection, and second one is intra-layer connection. So in yesterday's session, we have discussed about interlayer connections, that is feed forward and feed backward network. So here, with respect to these interconnections, you are having different types of interlayer connections. First one is fully connected, that is each neuron of the first layer is connected to the every neuron of the second layer. Then it is called as fully connected. And if it is not so, that is partially connected. A neuron of the first layer does not have to be connected to all the neurons on the second layer. So if it is need to be connected, it is fully connected. If it is not need to be connected, it is called as partially connected. And next one is feed forward. That is, yesterday we have seen about this type of network. It is a unidirectional network which has one hidden layer. And next one is bidirectional, that is backtracking is allowed in the network. And next one is hierarchical, which is like a tree-like structure. So if a neuron has a hierarchical structure, the neuron of lower layer may only communicate with the neurons of the next level of layers. So the top layers will only pass information, and it will not allow to communicate with the next layers. Okay. And next one is resonance. The layers have bidirectional connections, and they can continue sending messages across the connections of number of times until a certain condition is achieved. So here there are no limitations. It can communicate with a number of connections, and thus an output can be obtained. Okay. So as I said, connections are classified in two types, that is interlayer and intralayer. So with respect to this intra layer, you are having two types of connections, that is recurrent connections, which you'll be seeing in the next session about recurrent neural networks. Yeah, so these neurons within a layer are fully or partially connected to one another, and these conditions among the neurons of will be achieved before they communicate their outputs to the another layer. So here you will be having multiple connections within the layers, that is one will be receiving input, other one will be sending the output. So there will be an interconnection between the elements, and because they are allowed for backtracking, it is considered as a recurrent network. And next one is on center or off center, similar to your online and offline connections. Sometimes whenever the algorithm is running, they will be communicating effectively, and whenever the algorithm is not communicating continuously, it will be like a off surrounded one. Okay, so as I said, while talking about the model of ANN, you will be talking about interconnections, activation functions, and learning models. So learning is one important designing issue. Like without a proper learning of the algorithm, or without a proper understanding of the environment and the basic rules, it is very difficult to design an artificial neural network. Okay, so the brain basically learns from experience. So the so you can see the human beings basically tend to learn from many examples. Neural networks are sometimes called machine learning algorithms because changing of its connection. So because of a number of weights can be changed, interchanged, the network will be considered as a machine learning concepts, and it causes the network to learn from the solution to a problem. Thus, whenever you are adding or keeping on changing the weights, the machine learning will try to learn. The strength of connection between the neurons is stored as a weight value for specific connection. The system learns new knowledge by adjusting these connection weights. Okay, so the learning ability of a neural network is determined by its architecture and by algorithmic method chosen for the training. So you'll be having some set of rules which need to be ensured whenever you are designing an artificial neural network, and thus it also depends on the architecture, what you're going to select, like what activation function you are going to select. So accordingly the rules may also vary. So yeah, so the training method, basically because is considered as a machine learning model. So if you are using a supervised model, the training may be different. So supervised learning is considered like learning with respect to doing. So you will be doing a number of aspects, and accordingly from that the knowledge will be used for the learning method. Yeah, so learning method or reinforcement learning is also considered as supervised learning because it requires a teacher here. A teacher may be training set of data as an observer who grades the performance of the network results. So both unsupervised and reinforcement suffers from relative slowness and inefficiency, relying on a random shuffling to find the proper connection weights. So this is one of the issue which a developer need to look into whenever he is designing recurrent networks or unsupervised on reinforcement learning methods. So because back propagation is one important concept with respect to changing your weights, it is also comes under your supervised machine learning concepts. Okay, so information about errors is also filtered back through the system and is used to adjust the connections between the layers, and thus the performance can be improved. So a developer or the designer need to look into these things whenever he is designing a artificial neural network. Yeah, and one more important thing is about your offline or uh, online adjustments of your weights. So whenever your algorithm is designed with respect to your online method, it can operate directly, and a number of times weights can be adjusted. So depending on the things, one can categorize the learning models into offline or online. When the system uses input data to change its weight to learn the domain knowledge, the system could be in training mode or in learning mode. So here you are having two modes. What is one is learning mode, other one is operational mode. So when system is being used as decision aid to make recommendations, it is considered as operation mode. Okay, so whenever you are training your data set, it is called as your learning mode, and whenever you are giving some recommendations, it is called as operation mode, or it is also called as your recall. Okay, so depending on these two conditions, offline and online categories are done for this network. Okay. Yeah. So yeah, this is the last concept about your learning loss with respect to design issues of also about your ANN. So you are having some set of rules which are standard things to be understood while designing your artificial neural network. So there are variety of learning laws which are in common use. These laws are mathematical algorithms used to update the connections or the weights in the network. So Hebb's rule is the best and the oldest learning law which is used in many artificial neural networks, and the next laws are also dependent on this Hebb's rule only. So according to this Hebb's rule, yeah, if a neuron receives an input from another neuron, and if both are highly active, that is mathematically have the same sign, that is positive or negative, the weight between the neurons should be strengthened. That is the basic rule of this Hebb's concept. So this is very important concept. In examination point of view, these rules also can be asked. So everybody need to ensure that you are good at these rules. Next one is Hopfield law. This law is similar to your Hebb's rule with the exception that it specifies the magnitude of strengthening or weakening. So here in Hebb's rule, whenever they are having, whenever they are receiving the input from another neuron, if both are highly active, then it need to be strengthened. Then if both are not highly active, then it can be weakened, right? So it states, Hopfield law states that if the desired output and the input are both active or both inactive, increment the connection by learning rate or decrement. So if they're active, you can increment, or if they are not active, you can decrement. That is about your Hopfield law. And you're having two more laws. The next one is delta rule. Delta is nothing but the distance or the difference between the connections. This rule is based on the idea of continuously modifying the strength of the input connections to reduce the difference between the desired output value and the actual output. So whenever you are getting some difference between the desired output and the actual output, we basically add or remove some weights in the neural networks. So that is done by calculating the delta or the difference between the rules. Okay, so this network type is called as feed forward or back propagation, is also comes under this category. Okay, and the last rule is coherence learning rule. Yeah. So this procedure is developed by Cohen, who was by inspiring from the biological systems. So in this procedure, the neurons compete for the opportunity to learn or to update their weights. So here you'll be having like a winner and a loser among the given set of outputs. A winner only will be allowed to add or increase his weights, and his neighbors are also allowed to change its weights. And if it is a loser, it will not be allowed to add or decrease its weights. Okay. Yeah. So concluding the advantages and disadvantages of your ANN. So yeah, ANN can be used for many problems. Yeah. So ANN models are robust to noise in training data. The training examples may contain errors which do not affect the final outputs. So as there are n number of neurons, even if there is one neuron failure also, it will not affect the output. And also with respect to training also, even if there is any failure, still a training will be appropriately done. It is used where the fast evaluation of the learned target function is required. And ANNs can bear long training times depending on factors such as number of weights in the network, number of training examples considered, and the settings of various learning algorithms parameters. Okay, that's how these are the advantages of your ANN. And talking about the disadvantages, there are many disadvantages with respect to your ANN, because it is not so easy to design. There are some limitations or disadvantages about your ANN. So first one is hardware dependence. So basically ANN needs high computation parallel processing mechanisms or workstation type models because of the high end processing of their structure. For this reason, the realization of the equipment is dependent. So if because you need a high end machines, yeah, they are hardware dependent. And unexplained functioning of the network. So sometimes the functioning cannot be appropriately explained. This the most important problem. This is considered as the most important problem of your ANN. So when ANN gives a probing solution, it does not give a clue as to why and how. A solution cannot be explained appropriately using your ANN model. Next, assurance of proper network structure. So that cannot be assured by using your ANN. So and the next one is the difficulty of showing the problem to the network. So ANNs can work with numerical information. Problems have to be transferred into numerical values before being introduced to ANN. That is one important difficulty about your ANN. The display mechanisms to be determined will directly influence the performance of the network. Yeah, it may lead to a good solution, or sometimes it may lead to a bad solution also. This is dependent on the user's ability. If a user is not having knowledge about the functioning of the network, that may lead to some effect also. And the final disadvantage is the duration of the network is unknown. So how much time it will take to get some optimum results depends on the training values, and the network is reduced to certain value of the error on the sample means that the training has been completed. So depending on the training modules only, the output will be obtained, and sometimes it may not be a desired output. Okay. Yeah.